Good evening, everyone. Welcome to this exclusive system design workshop by none other than the world record holder, Mr. Vimal Daga. So, before we proceed, let me just give you a small introduction about who Vimal Daga is. Good evening, everyone. Uh, okay, so he's a senior principal IT consultant for all top Fortune 500 companies. He has served almost every sector, be it from IT to telecom to finance, you name it all. He's very popularly known in the industry as senior architect and integration guy. He's working on a vision of awakening the youth through a culture of right education. And today he's here with an exclusive use case of HotStar, making you all understand the technology behind this. How was this possible way back when HotStar had made a record of 25.3 million viewers during this India versus New Zealand World Cup semi-final? I'm sure you all are very well aware about this. This was a history, okay? And but I'm sure, being technical guys, what is the curiosity to know that what is that which helped Hotstar in achieving this? What is the technology stack which Hotstar has been using behind the scene, which helped Hotstar scale to an extent wherein it could accommodate 25.3 million viewers? I'm sure you all have this curiosity to the level next. And today, instead of the, the commentator out there, today we have our commentator for this, who's Mr. Vimal Daga, the world record holder. He's right here for next 2 hours to explain you technically how Hotstar managed it. You'll be learning a lot of new concepts, you'll be learning a lot of new technologies, and those tips and tricks which Hotstar had applied in their production environment, which even you, being a professional or a fresher, can use these techniques when you start working in an organization on such use cases. Yes, the core behind this is obviously the complete system design, because system design is a combination of technologies. It's a technology stack which makes the entire product available to you all in the way it is being seen to you. Would not like to take much time of anyone out here. So would like to give this stage to none other than the world record holder, the philanthropist, TEDx speaker, senior principal IT consultant, internationally recognized industry expert, Mr. Vimal Daga. Over to you guys. Have a great 2 hours of learning with him. It's an exclusive system design workshop. It's exclusive free because he keeps doing something or the other for the community. And this is one of his contribution towards it. Thank you so much.
Hey guys, welcome to everyone to this very uniquely created kind of workshop, right? Because I'm going to going to only give you the some facts and the information. I'm also going to give you the core detail architecture or how Hotstar has created a world record, okay, or created the world record, or create their own previous record of having 25.3 million live concurrent user in ISSI World Cup with India versus New Zealand, right? So it is not a small thing, guys, right now, because what I'm seeing right now, I'm doing this workshop live with you over here, and right now I can see in my portal I have 375 around concurrent user who are watching to me. Just 375 right now, even though that's a good number in the technological learning. But okay, in this particular match, okay, they had 25.3 million viewer, concurrent means parallel, they are watching this match over this live platform or OTT platform. How they manage this level of high end infrastructure, and this is the record they have created. Means none of the other platform or OTT platform, maybe Netflix or maybe YouTube, who have giving this live platform to stream the live, some match and something like this. None of the guys is provided this, right? So I have lots of content, guys, going to discuss with you very quickly if I go through my slide, because it is not only just to touch about some information. I'm just trying to go explain you the very detailed architecture, or I can say the entire design of this system. Okay, some of the screenshot that I have in my PPT, I'm just walking through very quickly. Okay, just to tell you, it is just not only the information. I am going to explain you very detailed architecture step by step to give you the entire knowledge, what happening behind the scene, what are the different services they use, how they connect all those services together to to complete this entire system design and created this record of the 25.3 million viewer concurrent, right? It's not the view record, it is a concurrent viewer happening. For example, right now in my current live based training, I have a 420 around concurrent viewer, right? Because just to watch the video, having the view might not be so much tedious in the terms of infrastructure management, but having the concurrent view is not the small thing. Lots of things we have to manage. Okay, so before I go ahead, this training, or I can say workshop around 2 hours, would be more on very techy or technical perspective, but I created this 2 hour in such a way, even though you guys are very new in this technological area, maybe freshers or doing engineering or pursuing a student, or maybe you are very expertise guys in this technical area, everybody will get something. I created this discussion in such a way that even though you are new, but you'll get the idea and the concepts. Because if you are planning to go for some top level companies and the job interview, product based companies, having the detailed knowledge of system design, and even though what I'm going to discuss right now, if you will get this level of information right, then it will give you lots of benefits in your system design interviews when you trying to pitch some top level company for your job. Or if you are professional, so working professional with 5, 10, 20 year experience, you will get also lots of new information, right, that help you to plan something in your infrastructure. If you're facing some issues, it will give you the idea. Okay, so this will be 2 hours. Okay, after the 2 hour, I will open the Q&A and chat box. Plus, I will also guys some more way to ask some further queries also after this workshop. Also, after this completion of the workshop, so any query if you have untouched from your side, we will try to help you, or also to help you in onward after this discussion completed, right? But one more thing, guys, in this particular this 2 hours today, I've compiled lots of information in these 2 hours. Lots of information that might not be publicly available, neither in YouTube, neither in some of the blog, or neither maybe in the HotStar and somewhere else. I'm also going to share those information to you. Okay, this is one thing. Plus, I'm going to explain you multiple concepts. For example, how high level design work, low level design work, how sharding work, or how the concurrency work, how we can do scaling, what a different kind of strategy of caching you can use. So a lot of concepts also I'm going to explain you here. It's not only about just giving the information about HotStar and this cricket news. Okay, I'm taking this as a use case. But in parallel, I'm going to give you lots of technical information also. So as a technical guys, it will help you in all the forms. A lot of vocabulary and the concepts also. Okay, so lots of concepts here is very unique. You won't get that information, again repeating, you won't get that level of information none of the YouTube channels and the website. Some of the slides you will see, it will be that I use here, that can be found somewhere, but lots of information that I'm going to provide and share to you would be very, very unique. Okay, so before I go ahead, very quick information about me. Okay, most of the guys might have done some of the training under me, but just who are just hitting and we are just first time we have here guys has been doing some kind of taking some information from my side, so it's good, always good to know about the instructor, right? So my name is Vimal Daga, and if you search my name in the Google, that's what I always say, you will get tons of information about me, what I do, my different press coverage, my our future goal and all the things, right? Or maybe LinkedIn may be the better place to know about me. Okay, and from here you will come to know that I almost work in all the technology area, because we want to set up the entire system of some big top product based company like Netflix or maybe Amazon or maybe Facebook or Uber or this HotStar. The main critical thing is there's almost all the technological products, all the technological stack used to create this entire system, right? Or to design this entire system, right? And because I work in almost all the domain, from security to network, from all the operating system to cloud to containers, Kubernetes, DevOps, databases, NoSQL, SQL, different caching systems, programming, microservices, every product I worked on in my career and worked with lots of companies also, in giving as a consultancy, as a training, as a solution architect, work with the top leaders. Okay, so I have very detailed knowledge of all the domain and the field from last 20 years working on this area, and with all the top companies of Fortune 500 companies. So I'm just sharing my skills, right? I'm sharing my information, right? And giving you the very much right knowledge to you, because I've seen especially system design is a one area you will find lots of video about system design of XYZ like Uber or Ola or Netflix and OTT platform. Okay, but the challenge is, okay, whoever giving this knowledge, okay, might work on one particular company, have only inside of that company, only on that company, also on one particular part. Okay, or let's say only on SQL or no SQL, only on microservices, only in one particular component, maybe let's say cloud. So but that is only one component, right, of the entire system. And knowing only one component, we can't get the entire information how the entire system work, right? So I think you understand what I'm trying to tell you here is I have very little knowledge of every component in this top product based companies. So maybe you can say whatever information I'm going to give you will have is a very much accurate and very much right, because without knowing the right information thing, you won't able to do something, right? It's not about just to go for the interview. It is about after the interview also work for the company. If you don't have the right knowledge, how you guys can work over there. Okay, so let's come to our main point and let's discuss about this particular point. Okay, so HotStar has created a world record in the match of India versus New Zealand. I'm so sorry for this. That particular match, India not able to win that point in time. Okay, especially for those who are listening from India, so they might not want to remind that moment. Okay, I think this semi-final or something like this, and as a World Cup. But that time, one of the company from the India or origin from the India is called HotStar, has created a record, and nobody has till date has beaten that record of having 25.3 million concurrent viewer watching that match, right? Or that particular match. So how they handle that level of concurrency, that is the key as a technical guys we should know. Okay, and for this I have lots of information guys to give you, but in a way that you will also enjoy this particular 2 hours with me, plus also get lots of information from very basic level, a lot of concepts also. And to make you understand, I'm going to show you one diagram, and there's a very famous diagram of that news. This diagram is published by HotStar only, okay, of that particular news or that particular day. Okay, and this graph will give you lots of information, and this graph I'm using as a base, okay, to explain you lots of concepts about concurrency, about management of the caching, different strategy, what cloud platform they use, how they manage the tsunami spikes, right? Hundreds more of information I'm going to showcase with you. So my entire PPT will cover lots of powerful architecture. It would be based on my base diagram, this one. Okay, so let me explain you guys about this diagram step by step. Okay, so this day when they have the ISS World Cup, maybe semi-final and something like this, I don't probably memorize or recall, but okay, if you try to see, okay, I think this time was around 3 p.m. what the time zone would be for India, I think 3 or 3:30 p.m. okay, when we have the toss. Okay, and because you can see from here, this is a million, and there's a 10 million, and obviously you guys know 1 million equals to 10 lakh in the Indians, right? And as a conversion, if you talk about the Indian unit. Okay, so this is around 2 or 3 million, means 20-30 lakh person was live over there as a concurrent. Or live means live, right? That I believe understand live. When I say live, I also mean to say concurrent viewer. So this is the time when they toss, and I have one very quick photograph of that particular toss. So this is the time, okay, on the news we had, okay, these many, okay, concurrent user, whoever won the toss after this sudden downfall in the concurrent user. And then one of the team start batting. I think New Zealand is the first one. On the first day they start doing the batting, and slowly, if you see guys, slowly as the time progresses, the number of users goes online, and after certain time, maybe after 1 or 2 hours, okay, we have around 10 million concurrent user over here. Okay, so what this diagram shows, or this graph shows, that continuously from this time onward, I think maybe 2 or 3 hours, okay, continuously, okay, we have 10 million plus. 10 million means 1 crore, okay, in Indian unit. So 10 million person was the audience or viewer was continuously watching that program match. Okay, so this information give you one interesting thing is that this live streaming is happening over the HotStar platform, whatever architecture they are using. I am going to explain in very detail, but whatever the architecture or the platform or the way they design the entire system of the HotStar platform for this particular news, this particular match, okay, they are very stable. Okay, so this continuity means you won't see sudden after some minutes it goes to 0. Okay, it goes to like they hit to 0, right? Because it means the application crash. We can't see any crash over here. We can't see any crash over here. Okay, it means that shows the platform is very stable. Continuously 10 million user was there for I think 2 or 3 hours. Okay, but there is no issue in the system. System very stable. That is also known as resilient. Okay, it does not mean that wherever they're hosting their servers, might not crash. They might crash, hardware might crash, application might crash, but it will be very much seamless. Okay, maybe some of the application crack or break, or the hardware break, network break, anything happen, or this called fail, but for the user perspective they won't see it. Okay, so as soon as something fail, okay, automatically they switch to new server, new setup, new rack, whatever it's called failover. So how they do, we'll discuss as a technical perspective. But this diagram so they are very much resilient, means maybe they break, but we don't see any downfall, or we don't see any break in the app. Okay, all the users continually watching this match. Okay, 10 million is not a small number, right? 1 crore person was watching continuously. Even though if we say some small down over here from 10 millions or maybe 12 million something, that goes down to maybe 8 million or maybe 7 million. Okay, you can see some downfall over here. This downfall, guys, if you see very detailed the time perspective, this downfall is at the 16th hour. After in the 50-hour match in World Cup, after 15 hours we have some strategical timeout, they have break. So I think this is 16 hour, or this may be 32 or 32nd hour, then we have some break. So that time some of the person left for some minute, again they come up. Okay, again they come up, and now after this you will see, okay, over here at this time suddenly my traffic goes down. Means a lot of Concurrent guys, they leave this particular match. I think from 14 million they goes down to 6 and 5 million somewhere. Okay, why? Because guys, that match was over one day, but I think that day they have the rainfall over there, and because of rainfall the match has been postponed to the next day. So this downfall is because of that the rainfall. I have the one small photograph is because of the rain the play stop, and this rain go for maybe for 3 or 4 hours. But if you guys if you see one interesting facts also here, even though this rainfall is going on, 5 million people was still there waiting for the match to start. But after some time they announced now match has been postponed to next day. But this information here, even though just for extra information, that's not so too much technical, but this graph show you that 5 million is still waiting for match to start. Okay, but what we figure out from this graph is one small conclusion. Okay, that till the time match is going on, we have 10 plus million user was live, concurrent user. Okay, and concurrent is very critical thing. Just a very quick information about the concurrent. It means it means if you have one system that is mostly known as server, okay, and there's other system where other user is waiting, that's called client. And when the client connect to the server for something, let's say to see the website, okay, this is called request and response. So client is request something, okay, and server is responding something. This is called request, and client is getting the response. Now whatever client is asking, let's say client say, hey, you are the Google server, I'm asking, can you help me to find the name Vimal Daga? So this data will go to Google. Google will use some program behind the scene or run the process, right, and give the data back. It means if one client come to Google, okay, then that server or Google or whatever the XYZ servers, they have to process your request and give to you. Okay, that is called one request. Okay, maybe after next second, next client can come, again the request, they will respond. Okay, next second, next time, next minute, again next client come, will again request, right? So it's not concurrent, it's not parallel. One client is coming, then second client is coming, then third client is coming. Let's say, just for your knowledge purpose, right, let's say one client is requesting, I'm writing C as a client, as a server, one client is requesting, and for one request processing the server, let's say server need let's say 10 MB RAM, okay, or maybe some CPU, or maybe for one request, okay, CPU for processing, RAM to put the program and to run it, okay, and we also need some network. Maybe let's say for this request and for this reply, we might have to give let's say 5 Mbps some bandwidth. Okay, it's obviously a rough number, but it may be on bytes or maybe kilobytes. Okay, it means if next client come after some time, again server has this much RAM available, CPU available, network available, they can give it. But if two clients come together, okay, in same time, that is called concurrent, at same point in time, simultaneously or the same point in time, it means both the request server has to handle at the same time. Maybe I can use the word called parallel. Okay, that is the very dangerous. Dangerous is very complex. Why? Because server can't say the client first and client two who will come first, right? They have to serve both the clients to make the happy both to happy both the clients, right? Because otherwise, if client two is getting requests after some time, they won't be happy. They won't use their services. Client want agile reply, quick reply. Okay, in the today's world. Okay, so server has to process all the requests. Means server need double RAM, double CPU, double network bandwidth. Okay, and in this case, if 25.3 million, okay, that is called 2.53 crore client goes parallel to this server, okay, as a concurrent users, it means we need for example, one client we need 10 MB RAM, means you need 25.3 MB, that much RAM, that much CPU, that much network bandwidth to reply to these guys, and that too the real time. Okay, yeah, if you're chatting something, sending mail, getting some website, maybe some delay might be, allowed. 1 second, 5 second delay may be not noticeable, right? But in the real time, if that's the match is going on, okay, we have to server has to reply in parallel on the concurrent, and that many users, that's what I'm trying to show you, that many user, 10 million user is there, and server, whoever is serving this match to this client or the users, okay, they have to process every client request by their mobile phones or the browser or iPad or TV, okay, in concurrent, the parallel. So think guys, how much RAM and CPU and network bandwidth they need, how much computing power, RAM plus CPU, mostly known as computing power, need by that server that is running behind the scene, or that too in very much resilient, means fault tolerant, means there is no fault, otherwise some of the client won't be happy. Okay, so we'll discuss those points. I'm just giving this very basic information, some terminology, those who are very much new in this world of technological area. Okay, but I think you understand the, it's not a small thing. Concurrent means a server has to reply in parallel. Now the interesting fact is in day 2, that give you the interesting fact. Okay, in day 2, okay, if you see here, I think according to my knowledge, only 2 or 3 are left of the New Zealand. Okay, suddenly you see one spike was the last few hours of the match of the New Zealand. After this are completed, maybe let's say 50-hour match, again you see sudden downfall, because next betting was of the Indian betting, and maybe they have some 20-30 minutes of break maybe. Okay, and again after the India start betting, again users start coming. Okay, this is the most dangerous area. Okay, for the user, for we as a normal user, it is so simple that we are go to HotStar and watch the match. For us it is very simple, but for us we are only one, right? But here if you see over here, this particular part, if we zoom it, okay, from around 14 or 13 or 14 million, they goes down to around 2 million. Suddenly 12 million, means 1.2 crore users leave this, actually they come up suddenly. Okay, if you see the rate, okay, this rate is around 1 million per minute, or maybe less than. Every minute these many users is joining the HotStar. Okay, per minute, then this many new requests come up, new users joining. Okay, it's very dangerous thing. Okay, and second dangerous thing is after they join, suddenly within a minute, okay, 2-3 minutes, all the guys leave. Okay, here if your infrastructure is not powerfully scalable, one is scalable, I'll explain in a minute, all right, and your scaling policy is not perfect, okay, you will face issue that client start leaving the HotStar, or you face the issue that the user won't like to join it, because as they join the HotStar, if you see any delay, in 1 second, 5 second, 10 second, they might move to next platform, other OTT platform or online streaming platform. But very easily they onboarding, okay, without any face the issue. But as a technical perspective, think guys, every minute or less than a minute, 1 million user here join, and within the next 5 minutes they again leave, again next 5 minutes or 10 minutes, 30 minutes, again they start joining. Okay, so this effect, what you see here, if I again take this picture, if you see this effect or this spike, only this spike, okay, this spike, okay, somebody joins suddenly, again they leave, again they joins here, first they join, then they leave, again they join. This is called tsunami effect, like a tsunami effect. And here, if your application or entire system design is not properly designed by the best engineers, okay, your application will fail, crash. Okay, and you know, this kind of company like HotStar and Netflix, if the application crash, it is a very bad thing for the reliability of their business, right? It's a huge loss in the business and the reputation, right? It's not a small thing. But just the game of 30 minutes, within 30 minutes, then the company might lose the entire business or their customer base, whatever customer base they have. But in this concurrent pattern, right, or this tsunami effect, they handle this traffic. How they handle? Okay, it is completely based off the scaling policies. And you guys might have heard about, anybody if you know about scaling, so there's a concept called auto scaling. But here guys, they're not using auto scaling. If they use the auto scaling concept as a strategy, it will fail. Okay, they will lose their customer. They use a very different strategy for the scaling. Okay, what strategy use, I will explain you in detail in some time. Okay, but anybody who know by chance scaling, they are not using auto scaling. They use a different strategy altogether over here. Okay, otherwise this tsunami effect will break their system and lose the entire business, right? Just in a game of 30 minutes, around 30 minutes. But by chance, those who by chance don't know about what is the meaning of scaling, just to give you the information, those who don't know about what is mean by scaling, for example, if there's one server is running, let's say the server has a RAM of 4 GB, have CPU, let's say of 2 CPU core, or let's say network bandwidth of let's say 10 Mbps or 100 Mbps. There's a one server, and the server we are running with some kind of applications, let's say website. If client is coming from the internet, okay, and let's say when one client need 10 MB RAM, some 10% of CPU, let's say 1 kbps of internet. Okay, just for this application. It's not like it's just not a thumb rule. It's depend upon application to application. So way we create the application, we have engineers who will do some kind of testing, and they find that this application, one client come for this kind of request. Okay, how much resources we need, it means RAM, CPU, and network is resources. How much resources we need? So they can set one kind of benchmark that this applications for one client we need that many resources. So from here we come to know, mostly we come to know by doing some testing. That's also known as network testing, load testing, 100 different kind of testing. By this we had some idea, not a 100% accurate idea, but like a weak or some idea that this system or this server, let's say the server number A, can handle just for example 100 client in one go. Okay, or as a concurrent client. And if you have more than 100 client, your system maybe goes down or becomes slow. If it has become more than 200 client, just for example, again the system might crash. So based on this thumb rule, who have found out, my performance team, my benchmarking team, when they run the application, they put the application in some testing environment, the other computers, and test it, and they come out with this kind of, let's say, conclusion or this kind of benchmark that this is what my one system can handle. Okay, so what we will do, we have some kind of tools running in the company who keep on watching this computer, and they keep on watching what is the current utilization of the RAM, what is, how much CPU is using, how much network bandwidth is using. They keep on watching. They are mostly known as monitoring tools. Okay, and those monitoring tools mostly known as metrics monitoring, because how much RAM is free is metrics, how much network bandwidth is using is called metrics. So they are normally a metrics monitoring tool. They keep on watching, and this tool is keep on giving the information that at this point in time how much client is coming, how much RAM and CPU is there. Okay, and in this metrics tool we can add certain rule, and we write the rule something like this. Something like this, that as soon as my RAM go above or memory go above 80%, or as soon as I got 100 clients, as soon as I get 80 Mbps network bandwidth been consumed, okay, or maybe my hard disk has been used that much, okay, then automatically launch one more computer. Okay, automatically launch one more computer, same exact copy, let's say server B. Okay, so based on this rule, because one server we know we can't handle the traffic, so add one more computer with the same application, and next client, whoever the next client come up, send the client to this server. So it is it is more like if I do here very quickly, it will be look something like this, that we have one server running, exact copy of one server also started. Similarly, my tool is keep on watching both the guys, we can launch one more. So more and more traffic come up from my client, more and more computer we keep on adding. Okay, this concept, guys, is called scaling. And who is adding this? Some of my tool who keep on watching, and something happen. So based on the rule means I say if traffic go about 80% of my memory, then add one more computer or one more server behind the scene. This server mostly known as backend servers, so add some backend server behind the scenes. This is called scaling, and this scaling, guys, is happening automatic by some kind of tools. Then it's known as auto scaling. Okay, so we have server A, server B, and server C. But there's one more thing, guys, between the client and server. Okay, we have one more system behind it that's called load balancer. Okay, so what happened when the client come, also connect to this guy, second client connect to this guy, third client connect to this guy, fourth, fifth, sixth. This is called load balancing, and here load balancer is using some kind of certain kind of algorithms. Okay, most commonly used algorithm is called round robin, but we have much more kind of algorithm we have. Okay, so because the load balancer, the client has to only connect to one computer, so one device. Okay, and behind the scene we can launch 1, 2, 3, 4, 5, hundreds and thousands of computers to balance the load. Okay, maybe something like this HotStar might be using. Okay, if you have 5.3 million requests, obviously one server can't handle, right? If we don't have a one computer having thousands of GB RAM and thousands of CPU, right? Obviously behind the scene, if 25.3 million requests is coming per second, or it is continuing the real time, definitely HotStar has hundreds and thousands of backend server running behind the scene, or running behind the load balancer. Okay, they scale it. Okay, and adding more computers is mostly known as horizontal scaling. Yeah, in one computer, if you have 4 GB RAM, if you increase the RAM in same computer to 40 to 140, increase more CPU, if you increase the resources in one particular computer, it's called vertical scaling. Okay, but adding more computer with exact copy of servers and applications are known as horizontal scaling. That is up to you. You're adding more computer by yourself manually, or you can write some program. They can keep on checking on the real-time traffic, and based on the traffic, you will auto scale the servers or your backend server horizontally. Okay, so how many computers is being used by HotStar, we will discuss in some time. But obviously, they are using the HotStar for handling these many client. They are definitely using horizontal scaling, and they might have hundreds and thousands of computers running behind the scene. But now how they scale? Are they using auto scaling technique? Okay, so I will discuss a little bit more about auto scaling sometime. As my intention here to just give you some vocabulary for those who are very new, what is a little bit about load balancers, okay, and what are about the backend system and the horizontal scaling. Okay, vertical scaling rarely we use, in some cases we use. I don't want to discuss right now, but mostly you will see auto scaling, or scaling normally means horizontal scaling. That's what we always see. Okay, so this was the guys diagram I was talking about. So it means, okay, if you are having a certain spike, okay, then again downfall, this is called dip, again we have a spike, okay, so 3 times. It means how quickly they are doing scaling. And guys, I want to give one more term here. Okay, one more term I want to give here is, if you are running one computer, okay, you want to add more computers or more server, more backend server. Why? More and more client is coming. This is called scaling, or I can say the better word is called horizontal scaling, because this is horizontal side we are adding. By adding the more computers is called scale out. Scale out means add more plus. And why I want to add more? Because more traffic is coming, more client is coming, more client is connected concurrent, parallel. But okay, if you add more computers, you have to pay more cost it involves, and you have to guys obviously do a cost management also. And for the cost management, tons of hundreds of things we can plan off. One of the small thing we can plan off is we keep on watching the client. Okay, let's say one computer can handle, one server can handle 100 clients in parallel, or if you are having around 350 or 400 clients coming in parallel, so we have 1 2 3 4 computers, 4 into 400 is 400. But my tool or my metrics monitoring tool is keep on watching, and when they found that now client is not coming, now we have only concurrent client is around 150 only. Okay, what can we do? We can shut down this computers. We can shut down this computer, because more and more computer you run, more and more you have to pay. Because nowadays, okay, we don't buy the computer, we don't buy the hardwares. Okay, so as a HotStar company, okay, if they want to put their computer, either they will buy one area, put there and create their own data centers called on-premises to manage everything. Nowadays, most of these companies, HotStar and Netflix and Uber, they don't manage their own data centers called infrastructure. Instead, they will take the infrastructure from other company, outsource it. That is mostly known as cloud companies, cloud computing companies, or public cloud companies. One of the famous one is Google, GCP, Azure, Alibaba, and obviously Amazon AWS. So if I talk about HotStar is using behind the scene AWS cloud. And AWS cloud, they will charge you per hour, per minute basis, depend how many resources you're using there. Okay, so if HotStar, if you're using one computer, second computer, more computer use from the AWS cloud, more they have to pay to AWS. Okay, so HotStar is a client for the AWS cloud or Amazon cloud. Okay, so for the cost management purpose, what they have to do, if the client is not coming, they can shut down the computers, okay, and only limited computer they run, so that this many clients can be handled. Okay, it goes down 10 million around. How quickly they do scale it? Obviously to manage the cost. Again, suddenly come up. Okay, how again have to do scale out. Okay, and for scale out, okay, most of the company, most of the cases, we always use auto scaling. Auto scaling means just keep on monitoring the resources. These are known as resources, and based on the resource consumption, take the decision online automatically and do the scaling automatically. It's called auto scaling. Okay, but here if they do the auto scaling, okay, the ways auto scaling work, okay, they can't serve these many clients, because here this client is not 10 20 100, right? Not 1,000, there are millions. Okay, per minute around 1.1 million, I believe, users join and leave. Okay, per minute. Okay, 10 lakhs users joining. and for, let's say, for 1,000 user, I need one computer. So think guys, for 10 million, how many servers or backend server we need? Okay, and if you use auto scaling, it won't work. Why I'm saying it's not work if you use the auto scaling? Because because guys, in the auto scaling, the challenge is those who by chance know auto scaling. Okay, auto scaling is keep on detecting. Okay, so if one server is running, okay, the way one auto scaling program is going on, okay, they keep on monitoring, and they found, hey, according to my rule, the system has been used more than 80% RAM. Now it means there's possibility more clients gonna come up, so let's go and launch one more computer. So they go and launch one more computer. Okay, but checking this rule, okay, checking this rule, and then go and launch the computer. Guys, again, this is the computer. Okay, and launching the computer means setting up, launching. Okay, normally takes some minutes and second. Let's say 2 minutes or 1 minute it take. Okay, maybe to checking this decision maybe take 10 seconds. Launching this computer, let's say 2 minutes. Okay, and after launching it won't work. After launch, you have to connect to load balancers, the way I explained to you. The client won't connect directly. Okay, what they do, I explained to you already. 1 minute. What they do, we always connect all the backend stuff has to connect, and also known as register to the load balancer, because client don't connect directly to the backend system. There's one called front end. Front end means client, the computer that the client connect are called front end. Mostly they are load balancers. Okay, so but load balancer is not the one where the application run, right? They're running in the backend system. So backend system has to register. So again, register will take some time. Okay, so let's say overall, by seeing the traffic is coming, or by looking at the traffic is coming, or my resources, okay, my traffic, my RAM, my complete resources been consuming. Let's say something like this. My graph of consumption is increasing. My auto scaling will take a decision, and based on the decision, they will launch the computer. And normally, guys, auto scaling, if you use, and if you ever use practically, it takes around 2 to 5 minutes to launch one more computer. Okay, but guys, here in this example, what I've tried to explain you, the user is joining per minute. How much user is joining per minute? 1 million user. So auto scaling might launch one computer or maybe 100 computers, okay, maybe automatically, but here it won't work. Okay, because it takes 3-5 minutes to launch the computers, but in 5 minutes we got 5 million user. How they connect? So they will obviously, they won't see resources to connect or backend servers to connect. Okay, so in this example, or in this particular kind of use cases, the use case, guys, here is called tsunami effect. You know, suddenly spike or dip in the spike. This is called tsunami effect. Okay, so in the tsunami effect, okay, it is the area where most of the real world application fail if the system design is not properly designed, or system is not properly designed. Okay, and in the design, if you feel what I say, if you feel that auto scaling will scale automatically and scale out and scale in, it won't work. Okay, so my point here is, those who know about auto scaling, this is one of the great use case where auto scaling does not work, because I need very quickly system come in and go out. Okay, so here they use a different strategy, okay, for scaling the computers. Okay, what strategy they use, I will discuss in some time. But auto scaling is not there. So those who by chance know auto scaling and those who by chance also don't know, I explain the auto scaling first, but auto scaling won't work. Okay, let's now guys, let's continue with for this diagram. Then I just keep on also giving you the information to you, some terms also over here. Now as we move forward, this is the time, okay, this is the time where India was not betting playing well in this day. So maybe clients was not happy. Okay, but this is the time which is very critical. Okay, this is a time where one favorite batsman come on the ground, and obviously I'm talking about Dhoni in this match for India. Okay, they come on the ground, and you see guys, as soon as Dhoni come, just see guys here, my traffic was here around 10 million or maybe 11 million, right? Live concurrent user in the HotStar. Okay, but as the Dhoni come, my traffic goes, and this is the one of the reason Dhoni, maybe one of the reason behind the scene why HotStar created the world record. Okay, because of the Dhoni. Okay, every minute, right, we are having around 1 or maybe around 2 million concurrent users start joining. So here this line, if you see, okay, in some minute, okay, they are joining around per minute 1 million or around 1.1 million customers are joining from 11 million to they reach to 25.3 million, and this the big spike, and this is what the guys world record. None of the OTT or any of the online platform, maybe YouTube, has created this record. Okay, this big number. YouTube, I believe the biggest number in the YouTube is, I think, 8 or 9 million in one of the some match and somewhere, some event. That was the highest record. HotStar is having the record that is a triple or 2.5 or triple the record that the second competitor they have, I think YouTube or something. Okay, but because of Dhoni, maybe, okay, huge number of customer base has been connected here. And again guys, maybe till here, if you guys see, till here we have a around traffic, and this very common typical traffic. Okay, even though guys, the biggest thing in the HotStar is all the other matches, IPL, normally the trend what they see is 8 to 10 million is a normal traffic they see always in all the matches. Okay, but here this is the very kind of very unique exception. They might not have thought about. Okay, but okay, the traffic is almost double than maybe 2.5%. Or the normal traffic is, or almost is 10, but now they reach to 25. It means their setup is so stable. There's one thing, and setup is so powerful in the terms of auto scaling. Okay, as every time, every minute, okay, customer 1 million, 1 to 1.2 or 5 million, 2 million customer joining, they still scale out. And guys, there's not a small thing, right? Scale out means you need that much RAM, that much CPU, that much network bandwidth. Okay, even though, okay, this was that match. This is the, I believe, the only match. I guess I'm giving very interesting information. This is the only match happened till date in the history of the technology. This is the only match happened where this match consume, okay, 1 terabyte per second internet traffic per second. In 1 second, 1 terabyte, okay, network bandwidth this match was consuming, almost average, or especially this area. And this number was so fascinating. You know why? Because if you talk about 1 second, 1 terabyte internet network bandwidth consumed in India, okay, and that is the 70% of overall India network bandwidth or internet bandwidth. So this is the day for this match, and HotStar is so much vibrant, powerful, stable network infrastructure. Okay, 75% of overall India bandwidth in this match is going to HotStar platform, or whatever the network platform they are. So guys, you know guys how big the India is, how big the network communication medium they have in the India, right? 75%, and I think 70 or 70% around bandwidth that all India has. Okay, out of 100%, 75% is being used in this match. That point in time, that level of stability on the network infrastructure this platform has, or this system has, and the HotStar for this match. Okay, and this is only for network. Same apply for servers, backend server, hundreds more thing, guys. Not a small thing, guys. When I talk about system design, from programming, from app, from from databases, SQL, from microservices. Okay, hundreds of things connect together. Then for us it look like one single match is going on, but behind the scene is a huge, big, multiple components. Component means load balancer is one component, backend server is one component, network devices is one component. Okay, your microservice, how you design your microservice, one component. What kind of database you're using, okay, what kind of file storage you're using is one component. Everybody work together. Okay, one of the system goes down, or one of the system slow down. Okay, then the entire system goes down or slow down. Okay, but none of the system goes down and slow down. The way this architecture has been designed, I will talk more about it in the architecture. But I'm just giving you that level of information that it's not so small thing. But just saying, okay, 1 terabyte traffic, okay, or just saying 25 million users. It's like 25.3 concurrent users. Think how much server they're using. 1 terabyte means 70% or 70% of the entire internet bandwidth of India that you're consuming in this network, in this match. Okay, so it's not a small thing. So yeah, so that's what, guys. I have one very quick, the photograph when Dhoni come in this match. Okay, comes to bat. This was the time. Okay, we got this traffic, and now you know why, guys. Why this traffic come up? It's not only because the Dhoni come in this match. This is not the only reason. Okay, this is not the only reason why I'm saying this. There's one more interesting fact here. It is again the game of marketing. Okay, the game of marketing. So what happened at this time, at this point in time, maybe the match might look very boring. It does not look like that India will win the match. Okay, a lot start losing the hope, and they start living. Here almost we have 10 plus, but here we reach to 10 million live concurrent user. Okay, but as soon as Dhoni come to bat, okay, the marketing team of the HotStar, they done their great job. The marketing team of the HotStar, okay, and what they have done, they start sending messages to the users. This is called push notifications. Okay, whichever the app they connected, mobile phone, iPod, TV, whatever the way they can communicate, they start sending a notification that are known as push notifications. Okay, to all the users. Let's say that point in time, okay, HotStar has 100 million user base. Everybody's not there, but I said this many users they have, and they start sending the push notification and say, now it look like we are still going to win the match. Dhoni is coming. Don't lose this thing. See, India is winning. You know, whatever the way they are marketing, guys, the way they curated this message, they they send this message. It's called push notification, right? And because maybe they are sending message to 100 million, maybe out of 100 million, 10 million might convert, 10% might convert, and that's what you can see here. From here, around 10 million plus user has been joined. Okay, because of these notifications, I believe. Okay, the key here is that is very interesting to know. It means this for management guy is one single message to send, but we are sending not to one single, we are sending to 100 million user, and a way that this will reach within a second. Okay, so how versatile and powerful that push notification system would be. Okay, it's not a small thing. So whatever the notification system they're using is so powerful. It's not a small thing that they send the message and message sent. Right? As I said, we send very quickly within a second to everyone. Okay, so here they're using some kind of notification system. Okay, notification related system. Either the system is created by HotStar, or because HotStar is mostly use AWS cloud, So behind the scene, guys, in AWS cloud, they have one AWS managed services. This is called SNS, simple notification service, but it's not simple. Okay, so this service they're using. So SNS is one service in AWS. Those who know AWS, so AWS SNS is one service they are using behind the scene, and this is a service, okay, they use behind the scene by the technical guys or management guys who use to send the notifications. Okay, and guys, this service mostly work on a concept called PubSub, publish and subscribe. So it gives a little bit more insight about this. So it is something like this. That in PubSub is a one kind of strategy or the model, I can say, where that whenever you publish any messages to this system or this platform, you guys, HotStar using the platform of AWS, and then AWS they're using a service called SNS. Okay, when you publish this, so what happened? Whoever subscribe to this service is called subscriber. They push it. Okay, so here they're using the push mechanism. Means as soon as you publish, this platform will send the messages, or it's called push notification, push it to all the subscriber, to mobile phone, laptops, TV, whatever the medium would be, they push it. This is called publish and subscribe. Publish means we are publishing. Who is publishing? The management guys, marketing guys. So as soon as they publish, okay, in this SNS there's a concept called topic. So who will subscribe to this topic? Topic means for sending the marketing message, sending the news information, sending the match live information. So every topic will do something. So who will subscribe to for this match or to the HotStar, everybody get the message that now Dhoni come and something like this. So this guys is one of the kind of model. Okay, queuing is a different model, message queue. But if you want to send any notifications, we have PubSub model. Okay, and whoever subscribe to that model, to that particular topic, everybody get the message. They don't have to come, we will push it. Okay, the information to their respective devices. That's what they use. So SNS as one top product they use behind the scene to send the message, and because of this, within some minute, 10 12 million, I not 10 12 15 more million users join to watch what is happening over here. Okay, but the biggest thing that happened over here at this point in time, and that is the reason why we had a huge drop and dip in the traffic. You know what happened this time? Dhoni, he lose the match. He out. I think run out something. Okay, because Dhoni out, and now that was the only hope in this match to win this match. And even though I think one photograph also of that match where the Dhoni run out. This is a moment. Okay, this is the moment. That is the exact moment what I'm showing this for this particular picture. Okay, where we had 25.3 means 2.53 crore user was there. Okay, and within some second, right, huge dip in the traffic. See, around almost from 25 million, we reached to around 1 million or zero. Okay, within some minute or second, I can say. Okay, and this is the biggest challenge. You know, for us, leaving the match is very simple. Okay, but for the HotStar, this was the one big problem they had, and they solved it. And they have already predicted this can be possible, and they already had this plan in their mind, and they already had that design for this plan. What I'm talking about, this very dangerous situation, right? You know why it's dangerous? Let me again take this diagram, okay, and how they handle this. So at this point when Dhoni run out, okay, traffic from this much within a minute, if you see within a minute, it goes, let's say 1 million, let's say 24 million user left the match. Okay, now challenge guys here is, okay, they left this. For us is so simple, we left the match, that's all. But 24 million guys left the match. You know what this means? It means if you're watching the match on your mobile phone, okay, let's say this match is going on. If you're watching the match in the mobile phone, there's a match is going on, a live match, okay, and there's a crossbar in the mobile phone, you know, close the tab. It is something like this. In this particular here I want to click here and click and close. Closing the browser, closing the app does not create an issue, okay, but the issue create when you guys and we guys as a customer click on the button called home. Okay, it means, let's say out of 24 million user, okay, out of 50% user cross the button or the tab. Means they close the app, that's okay. Okay, means they left the HotStar platform. But 50% user, let's say if they click on the home page, means within a second, okay, around let's say 10 million requests go to their home page. Okay, go to the home page. And you know what guys, whenever you create any app, okay, it look like one single website, but it's not. It is something like this. If I go to www.google.com and as I'm searching my name Vimal Daga here, so URL may be same, but here you searching in this app google.com, but internally they connected to this particular URL. This URL is also known as route, and behind the scene they are running this particular Google search in a different applications. Okay, what I mean by this, okay, let me explain you. So those who know a little bit about full stack development, okay, or maybe REST API or maybe route, they might understand, but let me explain very simple way that everybody can understand. So for us, okay, it is google.com is one single domain, one single name, one single URL. Okay, but in this google.com URL, okay, behind the scene, if you go to /search, it is a different product altogether, different app altogether. Different app. Okay, and when you go to this app or this URL, in this URL also known as route, when you go to this route, you hit to the different app running the Google search engine. Okay, and maybe this Google search engine again have a lots of backend server running behind the load balancers. So we have a load balancer here. Okay, but in the same google.com domain, same URL, if you hit /mail, okay, same URL, but if you write this URL or this route, you hit a different app altogether, maybe running multiple backends, maybe, or load balancers. Okay, but they are the mail servers. For example, if I instead of search, okay, 1 minute, if I just go and type mail, okay, you will see a different app launch, that is my Gmail. Okay, if I hit enter, you can see your Gmail start. Let me close this, I don't want to show my mail right now. Okay, but the launch behind the scene. Okay, so my point guys here is, okay, my point here is what I want to show you here is that it look like that. One more guys please. So it look like we are hitting to one server, but as soon as you hit the URL, okay, this URL is running a different app managed by different team, managed by different, maybe by different data center. This app look like one single app, but it's not, it's a different app altogether, maybe running in different cloud, maybe running in the on-premises, maybe running in the on-premises cloud, let's say OpenStack, maybe Google's GCP cloud. Okay, so what I'm trying to tell you guys here is in the HotStar, my guys were watching the live match here in this URL, okay, and this URL running with a different app managed by different team. Or when they hit to the home page, this home page may belong to same URL, but it's a different route, different app. Okay, so it means if everybody was here in this page, they are in a different URL, for example, this one or different route. And this route is been handled by a different set of team, maybe different cloud, maybe let's say AWS, and they are having lots of, what I was explained to you, lots of auto scaling, a lot of hundreds of computers running. Okay, but as soon as they click on the home button, they move to different URL, means different route, means different app. Okay, and certainly if they do have, the biggest challenge is what this app is providing. Okay, so they should have such a kind of design that they have to predict initially. Okay, because if you say no, I'm doing auto scaling, as soon as the traffic come, I will I will launch the computers. But here guys, if you see within a second or a minute, okay, around 10 to 20 maybe millions goes to home page. So does they have that system ready for this app to handle that much of concurrent users? Okay, even though guys, what HotStar say, if you go to live match, there's only one single API call on live streaming is going on. Okay, but if you go to home page, we have got a home page in such a way that there's lots of API call is going on, because we go to home page, we have different announcement going on, we have personalized data for you, we have recommendation for you, we have a your older preview of match or whatever the series or TV show you left. Every user has their own personal screen home page. So 10 million, 20 million goes to home page. So 20 million personalized page HotStar has to provide to you, okay, based upon your own particular account in the HotStar. It's not a small thing. Okay, so biggest challenge what HotStar face is not about the match. After they move to the home page, whoever move, okay, they have to face this, and they have faced successfully, and they have that kind of robust or very dynamic environment created. So they have done this. Okay, and you know why they can able to handle this request very easily, because this home page is one app, and they created this app with the proper strategy and the proper design or design pattern of microservices. This is the one of the big reasons they can handle this. Okay, so what is microservice? Very quickly, let me explain to you those who don't know about microservice in a minute, even though it's a big topic altogether. Okay, so you can think in this way: if you have created one app or one website, okay, and if the client is connected to this website, sorry, is connected to this website, okay, and this website say, if you come to me, for example, let's say this is a Facebook. Okay, so let's say this is a Facebook. Okay, let me open this one of the official page of the Facebook. Okay, so they say if you come here, and if you come here to see your post, so you want to see your post, or you want to create a new post, or you want to delete the post. So for us, it in the same website, it is in the same website, okay, same app, we have capability to create a new post, or to update the post, or to read the post, or to delete the post. Okay, this is more known as CRUD operator, CRUD operator. So applicants say, if you're doing all the things from the same app, right, means app is like a one program. In one program, if you give all the CRUD facility, create, update, read and read, okay, then it's not the optimized way, because it means all these three functions you have to write, and all the functionality, create is a different functionality, read is a different functionality, are you are you creating every time? Are you updating every time? No, mostly we read it. Okay, so we are not do create operation over time, delete operation over time. Mostly we do read operation. So mostly client will come for the read. So if we put every functionality in one single app or one single computer, they are mostly known as monolithic kind of design. That's not the better design in most of the cases. Rather, what can you do? You can create 4 different computers, 4 different servers. Okay, one server is only dedicated for the create operations. One server, we have a different program running with a different function. They are only doing the upgrade operation. They are doing only the delete operation. They are only doing the read operations. So for 4 computers running, 4 servers running, everybody is doing different functionalities. Okay, functionalities. Okay, now based upon the request, if you see suddenly we have a request come for the read, so we can scale the read functionalities. So we can add one more computer for read, we can add one more computer for read. It's called auto scaling again, scale out. Okay, and we're still running the update and delete operation functions, in the one computer or 2 computers, depending upon the requirement. So if we have one big service, let's say Facebook is one big service, okay, service here, but this one big service based upon your requirement, you created your own design and convert into small service, and this small service running in different computers is called microservices, and they connect together each other. Again, this is not a proper microservice class. I don't want to. This is one simplest example I can explain to you, to those who don't know microservices. So good plan is in your services, if you have one big service, if you can convert your services in different small services called microservices, and every service we can run in different computers. So depend upon requirement, particular functionality, or can say particular microservices, I can scale in, scale out, and do much more thing over there. Okay, so that is one great reason to run your application in microservices. So even though if you see the Facebook, okay, your post, what you see from here is read by different microservices. If you edit this post, is run by different microservices altogether. Okay, you send WhatsApp messages. If you search in the top for searching here, logging here, everybody is different, running in different part and different microservices. Obviously, the connect to the single some kind of backend databases. There's a different point. We'll talk a little bit about this, but having the microservice management would be very simple. And almost everybody is using a microservice kind of design pattern or design method behind the scene. Okay, so same thing happen, guys, here in the home page. Okay, what they have done, they have created a multiple microservices. So one single home page. Okay, so they created multiple microservices. Some microservice is going to display the data of the home page here. Let's say welcome page of HotStar and static page. Some here they're showing the announcement. Somebody is showing here the personalized message for account. Somebody here showing the maybe some other information over here. Okay, and whichever they feel certain traffic gonna come up, they will scale that part only. Okay, scale out. And for scaling out, what they have done, okay, let's say this is the one personalized home page, this part only. So because they are running this part in different microservices, and one microservice in one server number A, they launch one more computer, one more server B, C, and D. And guys, because within a second millions of requests come up, okay, so how quickly can launch more computers? Okay, that's also matter. So if you use a normal computers, this is called server, and if you guys know AWS, in the AWS when to launch any instance on the computer, or that can be done by a service called EC2. So if they use EC2, then launching the computer will take maybe 1 or 2 minutes. And because this take a lot of time to launching, and if you want to scale anytime, maybe auto scaling or maybe manual or other strategy, okay, to scale, it take at least 1 or 2 minutes to launch the new computers. And that is the reason I think 2018 HotStar mostly moved. Okay, they are launching the server in the instance like EC2 services to the container based. So container is one very powerful technology. Those who don't know, you can think. Those who don't know the container, you can think if you want to launch any operating system within a second or within less than a second, you can launch it. Okay, just to very quick information. Those who by chance don't know the container. Okay, now in this world where you want quickly computer can launch. Okay, HotStar is not using EC2 or launching the computer or server instances. Instead, they're using container based technology. And for management of container, you guys might know one of the great tool in the market that almost every company use, and HotStar using like anything, that's called Kubernetes. So they're using Kubernetes to launch the container. And Kubernetes has a capability. Okay, they have also capability to do the auto scaling. Okay, so if you hand it over to Kubernetes, say Kubernetes keep on watching for me based on this rule, and as the traffic requests more come up, more resources come up, launch one container. These computer guys want containers now, containers or servers, and add more computers. Okay, so Kubernetes can do auto scaling. It is known as like an autopilot mode. So just hand it over to Kubernetes, they will do for you. Okay, so they are using Kubernetes behind the scene. Okay, but again, because of this level of traffic, suddenly 10 million guys come to my home page. It's not a small thing, right? Okay, for this level of management, okay, because they know already, and because they have done lots of testing. Okay, and one of the testing guys they have done, okay, this is motion known as the proactive testing. Okay, they have done is this one, chaos engineering. Okay, so HotStar has the internal project. This is called Project Hulk. Okay, this project they use to do our testing. So whenever this kind of match going to come up, where you feel there's a very famous match, or there's a match happening between two teams, they are very competitive and they're very much likable match by the visitors, like India Pakistan match, or this match of India New Zealand match. All right, so here they have the Project Hulk and the HotStar, where what they're doing, they have lots of computers running, okay, behind the scene. For example, because HotStar use AWS behind the scene, and in AWS, okay, they have a lot of computers that are known by instance type. So they are using one computer having the instance type called C59X large. That one computer has 36 CPU and 72 GB RAM with 10 gigabit speed. Okay, if you see the second last number, that's what they use behind the scene. And this is one computer they're using. And for load testing and for testing their infrastructure, they launch, I think, 3,000 computers. Okay, C5.9X extra large. They launched 3,000 computer. That's max 108 CPUs, these many RAM, this much network bandwidth, just for testing, just to generate the load on the HotStar OTT platform. Just check how they're performing. Are they capable enough to handle that level of load? Okay, there are geography distributed, means 8 different regions, like one in India, one in Singapore, one in US, one in Europe, one is maybe Africa. Multiple regions, they are sending the load to check how they're performing as a proactive plan. And one of the proactive plan is they do chaos engineering. Okay, means they try to find out the proactively all the possible way or possible chances where application might break. Okay, especially for this they do tsunami testing. Okay, this kind of tsunami effect. Suddenly, this one when in between India and New Zealand, this effect. Okay, they're doing this kind of when this happen. So they do a lot of testing. If you shut down thousands of CPUs, 1,000 RAM, network goes down, one entire data center goes down, one entire region goes down. Okay, so they do all the testing as a proactive testing based on the traffic pattern they already had. So they use a machine learning there. Okay, so they do all the testing, what are the information they already have, and they try to create some unique informations, the unique kind of pattern to test all the possibilities. Okay, and by this they come to know, okay, when this kind of traffic come up, okay, I do Hull project, means all the kind of testing we have done. Okay, then for handling this level of traffic, okay, and what are the prediction would be from the older data with the machine learning, they come up with the architecture and say, now to handle this kind of traffic, we don't know, it's coming in the future, but to handle this kind of traffic we have to go for this strategy. So they create a huge strategy for all the area, from the network infrastructure, how much servers we need. So what they had done, they had created a 6 or 7 Kubernetes cluster. One cluster is, again, guys, more than enough to handle huge traffic, but they launched, I think, 6 and 7 Kubernetes cluster in AWS. Okay, and for the load balancer, okay, what I was talking about here, okay, load balancer. So they're using AWS ELB load balancer. ELB is elastic, means as the load increase, they will dynamically increase the RAM. But what they tested, they will work again with some particular point after that threshold. ELB is one powerful service in AWS. They will start breaking it. It won't work. Okay, it won't work. So they launch not one, they launch 4 or 5 ELB load balancers in AWS cloud. Because of their Hull project, they tested it like anything, and they know at that level of traffic, ELB kind of service also, it looked like very scalable by AWS, but after a certain point they break. So they launch not 1, 4 or 5 ELB. And here they light a lot of strategy. They create some kind of sharding plans or sharding strategy. Means they say, okay, let's say this is like 5 load balancers running. Okay, it's not small, guys. It's ELB is one of the biggest powerful load balancers in the world by AWS. And say this ELB is handling this kind of traffic. This ELB is handling this kind of traffic. This ELB is handling / homepage. This ELB handling live. This ELB is handling next traffic gonna come up. Okay, so any traffic come, the partition the traffic. This kind of traffic go to this ELB. This kind of traffic go to this ELB. This is called partitioning, and sometimes also known as sharding in the networking world. Same sharding we can do in the databases also, storage also, but they create some kind of sharding plan in the ELB to handle this level of traffic. So my point, guys, here is what I'm trying to tell you is if you have this level of biggest infrastructure, okay, we have to think in all the angles. Okay, maybe you guys are very new in technology, maybe you guys already been experienced in this world, but I'm just giving you the very high level view, that level of thinking you have to think of, right? And we feel that ELB is one of the great service, but it's not like this. At one level, at one point in time, they will also fail. And how they come to know? Because of this chaos engineering that proactively tested. I think I have one slide on chaos, I believe. I don't know. Yeah, actually chaos. So in the HotStar, the chaos engineering or chaos testing, what they do all the possible thing, all the possible checking. They're checking for the tsunami traffic. Okay, if something happened, then what can do? They're talking about the increased latency. Latency means, those who don't know, for example, if my client is there in India and they access the website running in the US, so my request go to US and come back from the US, how much time it will take is called latency. The total delay, total time is called latency. Okay, so if you're having huge latency or a lot of delay, again, it's not a good user experience, especially in the real time matches, right? Even though I don't like to have wait for 1 second, right? If match hold for 1 second, again, your cursor is moving on for waiting. So we don't like this platform. It's like a smoothly going on. So we don't need any latency. Okay, and latency is not only for the network. Maybe my app is running, but behind this app we have a databases. Okay, and what a client requested, my app is getting from the database, data is giving to my app, and app is handing over to my client. Okay, this is mostly known as one front end, back end, and database 3-tier architecture, for example. Okay, and here Again, between the app and databases, we have some delay. There's again latency we don't like. Every area, maybe my network is so powerful, okay, very quickly they reply, but between the app and database also we have slowdowns. So everything will slow down. This is called cascading effect. One slowdown, one piece slowdown, okay, in your system, the entire system slow down. Okay, so you have to check with the latencies on all the areas. How can we scale up? Scale up won't be delay. If you use auto scaling concept, it won't work. You move to Kubernetes, and plus some more thing we can do, okay, to use a different strategy for the scale up. Okay, so this strategy, guys, is not just auto scaling strategy. So we have one strategy, okay, that is known as buffer. Okay, so they use the one called buffer kind of strategy, where based on my productive plans, okay, they create a buffer computers beforehand. Okay, so as the traffic increase, they already have a buffer for 1 million. They already have a buffer of 2 million computer already running, either by EC2 or by the Kubernetes. They're already running. Okay, so they're not using auto scaling. As the requirement come up, then we scale it. So they don't rely on the auto scaling nature of it, means automatically launch it. Instead, what they're doing, they are using a buffering technology or buffering strategy for the auto scaling. Okay, so that will help them as the request increase. So they already have the buffer, and they give them directly, or running computer, running instances, and again launch some more in the buffer. So guys, here suddenly 1 million, 2 million keep on coming because they already have the buffer, especially this area, okay, proactively created of 2 million in the buffer. Okay, so they quickly give this. Again, as soon as they start giving, they launch some more in buffer. Again, they launch some in the buffer. Okay, so they don't use dynamic, launching the computer as they might come. They're taking from the buffer. And for handling this sudden request, and guys, having this sudden request also known as surge handling. So for this surge handling, they are using a buffer pre-provisioning, or also known as pre-warm-up instances, or pre-provisioning instances in the buffer. Okay, of for 1 million or 2 billion they have in their disposal, right? Is by handling for handling this surge handling or sudden request. Okay, so chaos is like a pre plan. So check any issues come up, they have all those plan they're doing, even though they have checking for CDN also. Okay, what is CDN? Those, again, you don't know CDN. It is something like this, that let's say somebody is watching let's say there's one website in US, and I am sitting here in the India, and I want to see the website. Okay, one possible way is I go to US and get the data over the internet. It takes a lot of time. It's become very best delays called latency. Instead, what they do, okay, this website, guys, whoever managing this website, this platform, let's say this is managed by AWS, guys. So my website is running on the top of AWS cloud. So AWS has a lot of partners across the world. Some of the partner, let's say I'm sitting in one of my cities called Jaipur in India. Okay, so AWS might have one partner in the Jaipur as one company, and the company mostly known as Edge or Edge locations. Okay, so what happened, maybe I don't have a better internet speed in my home, in my mobile phone, maybe 2G, 3G, and 4G, but between this Edge, okay, and this data center where the place running, they have a very powerful private private internet line connected with a huge speed. Okay, so what happened, rather than I will access the website from here, I and my laptop or mobile phone will go and access the website from here. But they might don't have the website copy. They go to this real server and they take the data and provide to me. But this time they will get one kind of copy here. It's called cache. So next time anybody, either I refresh the page or somebody here in the same region in Jaipur try to access the same website, they will get the copy from here. They don't have to again go to US. So in this complete setup, the website or the computer where my real website is hosted as known as origin system. And this computer where actually we are getting the actual website, but they're not the real. We are getting from the cache. Okay, we're getting from here. They are mostly known as edge location, or these computers are also known as CDN, content delivery network. They are the one who delivering the content to us. They don't have the real copy what they're delivering. Why? We want to use this because they are very close to us, and their local copy also, cache copy also. So getting anything from the cache and getting anything locally nearby you, you get a very powerful speed that is known as low latency. So almost all the websites in the world, okay, in the better design and the system design plan is, okay, what a content you deliver, maybe images and videos and the content, they will publish to all the edge location. They have partners across the world near in your cities, okay, and that is known as CDN. Okay, so AWS also have their own partners in the service called Cloud Front in AWS. But if you talk about the HotStar, they're not using Cloud Front of AWS. They are using a different third-party company, not from AWS. They're using a company called Akamai. So HotStar using for CDN, okay, HotStar using for the CDN a company called Akamai. Akamai is one of the biggest CDN network in the world. Okay, very, very powerful. So just a CDN content delivery networks. So very quickly we can deliver the content to our customer. So Akamai is using this. Okay, so there's the one point. But in the chaos testing, though there's some just information I want to give you, those who don't know. But for the chaos testing, okay, we have to check the CDN failure also. What happens if some of my let's say we are sitting in Jaipur, we have 10,000 users in Jaipur, and my edge location fail. This company fail. Okay, so we have to handle this. So now this time, these clients will directly go to origin. Okay, let's say 5% traffic is handled by this edge location. But all now 5% traffic go to origin where my HotStar real server is running. So they have to plan also for this. When suddenly this message, the millions of users come up, okay, how can we handle the CDN failure? So they also handle this. So just in the chaos engineering, it's like a proactive plan with thing in all the angles. Okay, so here we have a DevOps engineer, SRE guys. Okay, they do, especially SRE guys, engineers in a company who do this kind of level of testing to run this level of network, right? Because this is a real-time match, right? We can't take any kind of risk. Okay, so that level of things they are doing behind. So this is the project, guys. They are doing all those technological areas. Maybe for traffic machine learning, they are using machine learning, or maybe in AWS they have a SageMaker and some other services. They are using this. Okay, so now very quickly, so guys, this was the diagram I show you already about this traffic, because this is not a normal diagram. This gives you lots of information, guys. The clean view that what is happening behind, so how they are handling this spike, this tsunami effect, and all those things. Okay, and a lot of vocabulary I've given to you. Okay, this is what the guys, as the Concur viewer coming when the MS Dhoni got out. So 14 million, then 16, they reached to 25.5, and then they start dropping. That's what I explained you already. And this is what about something about HotStar. Okay, that day, this day, okay, HotStar got 100 million new users in one single day. That was the one record they created. Okay, and if they have there's many new user come up. Okay, new user, first time user come to the HotStar in one single day. And guys, when new user come up, those user information will be stored in databases. So they have to use databases. Okay, which one to use? Should you use SQL or no SQL? Okay, so again, one single applicant in the world, guys, is using multiple different databases. For some purpose, they're using SQL, some purpose they use NoSQL. Again, in the NoSQL, okay, depend upon requirement to requirement, what kind of requirement you have. Okay, for example, for the cache management in the application, they're using a caching server, the caching NoSQL databases. Maybe they're using Redis. Okay, so in some of the applications, the HotStar, they are using Redis as a database, or we have Memcache also as for the caching management. Okay, and nowadays, guys, you have that that service called continue watching service. Normally your OTT platform provide. They're HotStar using a different database called Scylla. So Scylla is also one of kind of very powerful caching database server, NoSQL caching database server, better than Redis. Just wanted to give you as a for knowledge purpose. They're using in the continue watch services for management of caches. Caches means it is something like this, and very quickly, if it is something over here, this is the client hit to your website or web app, and obviously, you guys, web app is just a program running, they don't have the data, so they will hit to your database, okay, and get the information and give to you. But mostly, guys, database is running, putting the data in the hard disk. This called storage, and the speed of storage is very slow. And because storage is so slow, that makes everything slow down. So you put high level internet speed, powerful RAM and CPU, but if storage is slow, everything slow down. This is called bottleneck. So storage is always the bottleneck. So what we do normally, we put one server here, one unique different kind of database here, and the database responsibility is only doing the caching. Okay, and database is they have the capability to run the database in the memory. It's called in memory, means directly the RAM, and RAM is very powerful than the speed in terms of speed. Okay, in the terms of reading the data. Now what happened? Next time when the client come to this website, the website always read data from here. Okay, but initially this does not have any data. So first time this data they read from real storage. Obviously it takes some time. Then they give back to application, and application provide it. But this point in time, this data they cache it, stored locally in memory in this server or in this database server. Okay, so next time when the website come up again from the client, if they're looking for same request, they don't go to the database or real database because they're slow. They're actually giving from their cache memory or from the RAM, and they're so fast and very quickly they reply. Okay, so this is the one of the area, okay, where we can use caching, and for this caching we need some kind of caching database. And one of the famous example in market is Redis or Memcached or much more like Scylla is the example we use here. For the caching, for the database we use Redis. Or for caching, for the CDN we use CDN network. This is also a caching server, right? So networking world we use CDN for the caching. Okay, in this area, this part of the area between the website and the backend and the database, we use a caching database server like Redis. Okay, and there is one more kind of caching server we have. Mostly what happens when some client want to connect to website, in the front of website we have one more website cache. So rather than we hit the website and run the program again and again, maybe we have some program, there's static programs, they always give the same detail. Okay, maybe some kind of processing we are doing, they always get the same result. Okay, so we can also put one more caching layer here. This is called Varnish. So Varnish is one of the great product we use for web cache. We have some caching in the client side also in the browsers. Some of the data is very static. Okay, like some kind of JavaScript libraries like Bootstrap and jQueries. We also ask them to cache. Don't again ask me to download. So cache is a big thing. Okay, for the client browser, we are caching. We have from the front of the web server, we have a caching. This is called web caching. Between the web application or backend or databases, we also caching. That is called database caching. Okay, to deliver the network, your actual network nearby you. Okay, it's called CDN. There's also caching. So without the cache, thing will slow down, right? So again, as a great SRE engineers or DevOps engineers or the entire complete solution architect who have to design the entire system, that's called system design engineer. Okay, that level of thinking you have to write. You have to put in your mind. Okay, to do the things, or to do this kind of level of setting. Okay, so this one. So this mesh level of guys users they're getting is, okay, so depend upon what database they can handle. So if you have 10 million users coming in one day, so these user information we have to store in one kind of database where we can store. Okay, so maybe this is the user information, so they can use MongoDB maybe for it, because MongoDB has a capability okay, to store, okay, big data, huge data very quickly, because MongoDB has a way to get a big cluster so that they can distribute the data in the cluster. They can use MongoDB, or they might use some kind of enterprise version of MySQL. Okay, then they have the cluster of the MySQL with lots of some running parallel. Okay, and to get the data from a customer, because these many customers come up, so they might use MySQL also. So again, guys, MongoDB has different use case, MySQL is a different use case, Cassandra is a different use case. I don't know like which one to use. Redis will use for other purpose caching. Cassandra will use for searching of the document, because maybe this user is there on the HotStar and they start searching some TV show or something like this, so giving a quick search on the text and the document. Okay, so they might use Cassandra. So nowadays, guys, they have some specialized version of Cassandra. Okay, Scala they can use, or I can say in the HotStar they're using a one product called Solar. Solar is one product they're using for searching. So anytime you guys go and search something on the HotStar, some TV show something, okay, previously they were using Elasticsearch, but nowadays using the Solar, that is more powerful, more performance oriented product in the HotStar. So Solar is one great product. You can think it is a competitor of sorry, Elasticsearch. Okay, this is the product I'm talking about. Sorry, yeah, this one, Solar, for searching in something in a distributed way, especially querying or full text. So they're using it, or otherwise you can use Elasticsearch also for searching the text. So my point, guys, here is, if you say I have the application, so I use MongoDB or Oracle or MySQL, that is not the better or right answer. Okay, again, this is the one of the biggest challenge everyone facing is because I've been consulting all of top companies. They've tried to focus on one database. I said no, just understand your requirement. If your requirement is only searching the text, okay, or the description or something like this, use Solar or Elasticsearch. If you want to store some real-time data like IoT information, use Cassandra. If you want to store the entire profile of the entire users and product, use MongoDB, document oriented. You want to use for storing the caching information as a database, use Redis or Scala. Again, in Scala and Redis, they have a differences, right? So lots of knowledge base if we have, and you know the right use case, what I'm looking for, you are very clear about what kind of design you want to design, or system you want to design, and you have a clarity about about what would be the end result, what kind of outcome you're looking for, and you have the entire knowledge of all the different products and databases available, then you can plan properly which one should we use. Okay, Solar is being used by chance in the HotStar just for searching purpose. Okay, now this was the guys, a lot of information given to you that day. This much TB bandwidth consumed, I told you already. These many million requests, messages being given, broadcast messages or post messages given from the HotStar management guys to us. A lot of the information I almost also explained to you. Okay, that day guys, 2.55 to 1.3 million live you see that time. Okay, and guys, this was a historical number. 2012 YouTube has the highest number, but till now HotStar is the one who win all the live number subscribed. Okay, that day India's internet 70% is been consumed. Traffic is not consumed, gone to HotStar platform. And HotStar has no personal platform actually. Okay, they are hosted everything in AWS Cloud or CDN like in Akamai and something like this. Okay, so but it's about the planning. This was I already explained to you. This was I already almost explained to you. Like to generate the load for testing. Okay, so this also push notification. I explained to you. This message has been gone to the things. Okay, chaos I explained to you. And this diagram guys, almost I explained to you. This was the diagram you have. Okay, so behind the scene guys, let me give you some more information over here in this diagram. Sorry. So we have a client user over here. Okay, and this user is been connecting to the load balancer, like hostar.com, something like this. Okay, then instead they connect to website directly. They use the cache, web cache layer. This is called Oneness, is one of the very powerful product we use. Okay, now based upon the further sharding means what they're coming for. They're coming for the home page. They're coming for the live match. Okay, we will redact the traffic either here or here. Again, everybody has their own load balancers. Okay, and most of the application guys in the HotStar has been created in a Java as a language, and for hosting the Java applications it's called Java web application. We need some kind of not web server, like an app server. JBoss is one of the very powerful web app server from Red Hat they use, okay, for handling. And JBoss also have a way to create a cluster. Okay, and all the information what is coming up, they are storing in the MySQL. Okay, with the MySQL, lots of computers they are having for distributing the data. Okay, for the reading and the writing. Okay, and anything you want to search, okay, we have a Solr. So if you come to search.hostar.com, searching, you go here to search some TV shows and something like this. Okay, again we use Solr here, or maybe Elasticsearch to search. So this was the guys high level HLD high level design. Okay, it's not a complete design, but most of the part I explain you extra to give you this entire information. Okay, then this is also what I explained to you. One more thing guys, there's a concept called S3. Okay, S3. So S3 is one kind of storage. Okay, so it's not database. So whenever guys it is something like this, it's something like this. Whenever any file come up, we need to store the file. And if you want to store the file, we need a file storage. And one of the biggest file storage service in the world that give you very high level of performance. They give you almost the infinite space. Is called S3 by AWS. Almost all the big top company in the world, they're using S3 for storing the file. File may be image file, video file, text file, PDF they use. Okay, and now because this is about live streaming of video. Okay, so all the video either the coming on the or from the live, okay, or whatever video you uploaded or the production house uploaded a movie and so in the HotStar, every video is actually been sent to the S3. So S3 is a storage where all the video has been actually stored. Okay, and then it will be given to the customer. Again, they have the particular strategy for this. Okay, because in some time storing S3 is not the good thing, because when you talk about the live streaming, we can't do this for we store an S3, then read from there, and then we give it, because it gives a lot of latency and delay. So depend upon your OTT platform. Either they are giving you a facility of live streaming, like cricket matches, or they want to give you a movie and video pre-recorded kind of playbacks. The playbacks on videos and audios and to you. Okay, but if you want to store the image and videos and files on audios, they use S3. Now, depend upon the requirement, I have some slide on it. Okay, slide on this. So this is the one slide I have. So if HotStar is giving you the VOD, video on demand, as a pre-recorded video, this is what kind of setup they use. Or if they're giving you live events, this is what the kind of infrastructure they use behind the scene. Okay, so let me explain to you. Before this, very small information I want to give you here, okay, about this part. Okay, so again guys, if any live video is going on or live streaming going on, because HotStar is using behind the scene AWS, okay, AWS, 1 minute. So AWS has one very powerful service in AWS is called media or elemental service. Okay, so this service is what they do. Any live channels who is recording live, AWS has a capability that has been managed, that is for running for the HotStar. It's called live, elemental live. They have plugin. So live streaming of the match will directly go to this service. They will capture the live events or live stream, okay, and that live stream will be injected into Media Connect. So this is called inject here. Now what Media Connect will do? Now Media Connect, what you want to do? This is your live streaming, or it is a video as a recorded video coming from some production host. So Media Connect has a capability, what I was talking about, has a connectivity. So Media Connect, okay, can either provide the video directly to you, to the end user, the customer, or Media Connect can take the video and also store for the playback to play in the future in the storage called S3. So what you want to do? Or you want to do both? So normally in the live streaming, you normally see guys, in the live streaming, we can see the live streaming, but we can also go back at the same point in time. Right now guys, you are watching me in the YouTube, you guys are listening to a live, right? There's live streaming, but you can go back also, right? You can start from starting right now. You can again listen to me right now, because this video at the same time is storing somewhere in the storage, in the file storage. Okay, so you can go back and see it. So HotStar is using AWS, and in the AWS they have Media Connect, a kind of one service. They have capabilities to store the data in some storage, in this case S3. And at the same time they also sending this data live to us, and sending live to us, they're using this Media Live service. Because again, sending live is not the small thing, right? Because sending live also we have to do a lot of things, right? One of the things that we have to do is any live streaming coming okay, any live streaming coming is a live streaming, but we have to send the data to my OTT devices, mobile phones, and every OTT devices support different format. TV support different format, different size, okay, mobile phone different size, okay, everybody has a different protocol support. For example, if you talk about TV mostly support for live streaming, they support RTMP protocol. If you have iPhone, and the iPhone, if you see the live streaming, they use HLS protocol. Okay, browser media player, they support MPG dash protocol. Okay, everybody support different protocol like this. What are the protocols also? Okay, so we need some kind of video processing tool, also known as a media server. What they do, they will take the data in, process data, okay, and convert this live video streaming into multiple different format. Okay, that can support my multiple devices that support multiple different protocols. And doing this concept is called transmixing or transmuxing. So this service, live video processing, is doing transmuxing for you. Any data coming in the real time by some source, okay, they're converting or transmuxing into the multiple different things. So they convert multiple protocol, even though they converted different format also, different size also. Okay, whatever is being supported. TV has a bigger size, mobile has smaller size, so different size and all the things they do for you. That's called a transmuxing that they do. That's been done by media server as a concept, but in the AWS server or AWS cloud platform, if you ask who can do media server for you, so they have Elemental Media Live is one product they can do for you. This part they will do. So this also been done here. Okay, and one more interesting thing is, every mobile phone has a different size, pixels. Okay, their bandwidth is different. Right now, you guys are watching me, you might have different bandwidth. You are running, somebody is running a 2G and 4G. Everybody see a different kind of bit rate or different size or different bandwidth, maybe 1024p or 4K or 1K, right? So it means my live streaming that is going on, or maybe recorded video that is going on, will automatically adapt upon your current stream and your support. So behind the scene, we have to encode the data, or we have to convert the data in such a way that we will adapt according to my devices or my customer devices. And this concept, guys, is known as adaptive bit rate streaming, ABS. Okay, same live streaming, somebody in watching 4K, same live streaming, somebody watching in TV, some live streaming are watching in 720p with different size. Okay, so you are adaptive, but from my server or from media server, we have to give that level of stream out. Okay, to you, this giving out is called egress. So media server give that kind of packaging to you. It's called egress, depend upon your what you are supporting. And you also support dynamic. Suddenly your network goes down, your bitrate change, your P change, your format of codec change. Okay, this is called dynamically change. So that also supported. Okay, so when you do a system design, you have to write the features. What features you want to provide. So one of feature would be in the live streaming, my client can see live without any delay. This is one feature. Second feature can be they should be dynamically adapted. Next feature would be if the device is TV, mobile phone, they will have different encode or codec. One feature may be maybe if they want to go back in the live streaming, they can go back. It means my video has been stored also in the storage, they can go back. Okay, and they can go back to any point in time. So it means I'm not storing the entire video, I'm storing the video in the chunks. Every video will be divided into small chunks. So anytime they can go back to that point, end that point. So you don't have to load the entire video. That part of the video they can load. Okay, so these are the features I wanted in my system, this app. Okay, so it's called features. What are the features you're looking for? And based on the feature that you have to give to your client, you have to design the entire system. There you have to go for non-functional design, right? Where the entire high-level design, low-level design come up. Okay, so here, guys, all those components I explained to you. Okay, all this example, load balancer, caching, all the things I explained to you. Okay, it's come in the high-level designs. But when you start creating this setup, okay, you have to write an app, you have to create a caching layer, to connect a caching layer, design a schema of your databases or SQL or NoSQL, okay, to support, because launching on the cloud, connect the dots, connect all the components will give you a technical platform, but your app should be run, right? For running the app, you should know full stack. You should know how to do database connectivity. You should know how to kind of build different databases, different sources, how to better create a code, how to write a code in the more optimized way while by checking, time complexity and big O notice and hundreds more things. Which data structure to use, which data algorithm to use, right? How to get a machine learning. It means I'm talking about entire technology what is exist okay, in the market. If you know this, I'm not saying you should know every bit of it, but at least you should have an idea, conceptual idea, what is happening, okay, what is happening, what component is doing what for you. So this is one guy's experience I given to you. This is what the real time is streaming. Okay, so real time, if you want to do a store also in S3, okay, same time also going to give the real time platforms. This is what mostly everybody use. Okay, so anybody can go back. Okay, they can preview because of the S3, and they can also see the live real time also. And the different format, HLS format, Dash, and other format the media service is doing for you. Okay, this is general diagram from AWS, but in the HotStar, they're not using Amazon CloudFront for CDN. They're using Akamai that I already told you. But otherwise, almost this thing is being used by HotStar. Okay, there's some more thing about the HotStars. 25 million concurrent come up. And behind the scene, guys, they're using Kubernetes cluster that I told you already. A 10 Kubernetes cluster they use behind the scene. That's a big thing. And the interesting thing is the entire match go autopilot mode. You see the last line, autopilot mode, because of Kubernetes and the way they do the designs, autopilot mode. Okay, and because here, guys, lots of things we have to do automated. For automation, we normally need CI/CD. One of the great tool in the CI/CD is called Jenkins, but here they use GoCD. In the HotStar, they use GoCD instead of Jenkins. Okay, and for the automation, we need to automate the infrastructure. They use Terraform. Okay, they use heavily Terraform for this. Okay, those who know, that's giving this information to you. Otherwise, there's not so much important. Okay, and almost this part I explained to you. If you want to go for VOD services, video on demand, we don't need any live streaming services. But if you want to go for live streaming services that I explained to you, live streaming, go, and then all the conversions and transmashing and all the things gonna happen over here. So guys, this is the slide I have this match, guys. By chance, Dhoni out, and this was the diagram show you. This is again one more diagram from the current match of India Pakistan. Okay, similarly also, guys, same kind of spike you can see on the match happen on 16th June. So this we can see very quickly, and this also give you a very idea, right? When you have break, some rain happen, sudden somebody out, now somebody miss the hope of winning and something. Okay, now match does not look good, interesting. So lots of information get it, but for the non-technical point of view, this might give you non-technical knowledge, but as a architecture point of view, system design engineer perspective, you should be very much well aware about this. Means here we have a high spike and suddenly goes down. Means fail out happen and suddenly spike come up. So in this match, by chance, we have no tsunami effect. Don't see any tsunami here. Okay, they slowly go up, slowly go down, then slowly go up. It can be handled, maybe handled. It's a very common use case. But the example I pick intentionally about India and New Zealand match, that's very powerful. Sudden spike, sudden goes down, surge, that's called surge issues, and the tsunami issues. That was a very interesting use case. So as a technical, guys, this was the match of India Pakistan 21. There's also one record they created because most watch match that there was the recorded matches. That's what most watch match. Okay, and this was the traffic of India New Zealand match. They go till here, and by chance, I'm so sorry for this. Those from obviously mostly go for India, we by chance lose the match, and that was the that was the movement of for the HotStar guys. HotStar guys say I am come from India, and there's a two big thing happen. One is good and one is bad. Bad thing is India lose the match. Good thing is we create a world record as an India company. Okay, so we have to balance our emotions, how we showcase, right? India lose the match and we want to get a record. What to do, but I don't know how they manage, but that was the one thing happened right on that day. The guys entire conclusion is, okay, what I'm trying to tell you as a small note from my side. What I want to tell you to everyone is, if you are belongs to technical field, and if you want to be a leader in the technological area, okay, then knowing the entire system design is must. It's not only for getting the job in the top company. If you want to get the job in top company, knowing the system design is very interesting. And even though I can give the guarantee, whatever the explanation I've given to you, if you explain somebody 10% of it, what I explained you today, just in 2 hours, okay, just 10% of it, it give you a lots of benefit in getting the job. I'm talking about the freshers guys. Okay, and experienced guys might get some idea out of this discussion, what I discussed right now. Okay, but if you want to lead yourself in the technological world, okay, from starting a career till the every year, the way you grow in your life, if you want to be leader, okay, and want to work for the top companies, or want to solve any kind of challenges, this kind of big use cases, guys, think who created this architecture. They are the top leaders, right, in the technology area, or top solution architect who build this level of infrastructure I was talking about. I think how much knowledge they have. Okay, so very limited guys in the world who have that level of knowledge, who can plan and build this kind of system design. Okay, only challenge we have in the market is we don't have any system design program available, okay, training available, okay, who give the entire component knowledge, this idea, multiple strategy, okay, from low level to high level designs, all the things connect to there. Okay, no program available. I'm talking about the practical program. You can find hundreds of programs available. They might talk about basic thing like only caching or only sharding or NoSQL, basic things. Okay, but only those things not enough, right? You connect multiple caches, we have multiple layer, you have to do sharding, multiple components we have to connect, multiple type of testing we have to do, or where to fit what kind of microservices, what that design we have to use. Okay, we don't have any practical 100% practical system design course, right? And that was, guys, we from Learning School has taken this opportunity, and because of my skill that I learned from last 20 years, every component I explained to you, I've worked dedicatedly, not for this company, but the other company I've solved that of their use cases. So we have created one program. I think most of you guys already know that program that we created in a very in a price that anybody can afford it, because knowing these level of, I have the course content also with me that you guys might know. Okay, I think this is one of the biggest course content of the system design that cover everything about LLD, HDL, caching, databases, big database, because if a huge data is coming, you should know how to process it. For example, HotStar is putting this big data in the Hadoop or Spark cluster in AWS called EMR services to analyze the thing what is happening in the past. Load balance, high availability. So these are terms we have. Okay, but every time, okay, I created this program in such a way that everything we create by ourselves, every component we are going to create, and this will be the only program in the planet. I can give the guarantee. Only you can search also in the Google, anywhere in the Google. Do you have any 100% system design program available where all the components learn practically, then integrate together and create this kind of level design? So my plan is after I complete this program of system design, what I'm talking about right now, my plan is to build this kind of infrastructure. What Netflix is using, what Uber is using, what this guy is creating, with lots of test, and it's like our creator platform. Okay, maybe you want to give this platform as a service to other company or as a consultant, or maybe this is for learning, so any company will want to work on every aspect of the component, so it will give you very quick jump in your career, in your life. So this is I believe, according to my search, this is the only platform that contain everything. Okay, all the Kafka and all things, from basic to all the advanced, plus how to integrate and how to practically implement this. There's no prerequisite for this. We're going to start things from very zero. Okay, but this is not the interesting information from my side. Interesting information that I want to announce right now, again, because guys, we as Linux will be working heavily for one reason of empowering the youth, especially in India. We're working on the Making India Future Ready as one of the campaign, where even though this program we open for everyone, for engineering student in the corporate world, and make this program very cheap. Okay, that is only 1,50,000 rupees. That was the price we are offering. Okay, that most of you guys might know because we already announced this program long back, and we're going to start soon. Okay, but because I want youth to be very much trained in all the things, because there's a myth in the market that as a fresher or as a pursuing a student, I should know limited things to start the career with. I don't believe on this. I believe as a engineering student, at the time of engineering, knowing this skill is very important. Even though if you see, this is the content of your BTech or engineering students in the books you have. The only thing, you're not learning there in the right way, what it's supposed to be learned. So it's a myth that learning this thing I require 10-20 years, right? No. While pursuing the engineering or before complete the engineering, you should know every aspect of it, and you should know practically and how to connect and solve the things. Then it will be known as actual engineers. Okay, to support and to give the support that every engineering can learn this level of skills practically. That's why we give them ecosystem design. What we have doing as a Linux world, we are providing this training, okay, this entire training absolutely free to the pursuing student who are the part of my Earth program. So Earth is one program, guys, we have created. Those who by chance don't know, we have a website called writeearth.com. Okay, so we have launched the third version of Earth this time. Again, this is one kind of fun 12-month program for other purpose, to get the top engineers in the world. Okay, top in the world, and that is a different hundreds of things is there in this program as a topic to be covered. These are the lot of topic we cover here in this 12. It's only available for pursuing student. So anybody who part of Earth 3.0, okay, and this is the live announcement I'm doing first time. We haven't announced yet. I'm waiting for this day to announce. So anybody who are then Earth 3.0, that we are going to start soon next week. Okay, we are giving one of the biggest program on the planet and one of the biggest program from the Linux world, okay, to these students who are the part of Earth 3.0, this entire system design program, okay, free, 100% free for these guys who are part of Earth. Okay, we're not going to charge the system design fees. Yeah, for the corporate world, because Earth is not open for the corporate world. Anybody who want to learn system design, still this program is open for registration. And for me, this is the one of the kind of cheap price I can say, because normally in market system design price is 2-3 lakhs, 10 lakh rupees also. That too is mostly theoretical without practical informations and practical indications, but this is the 100% practical. So for me, this is a very cheap price. But for the engineering student in India, only for Indian students, we have given just to working in one single vision what we are working on, especially for the Indian youth engineers, that is empowering them. And I want they would be the top technical leaders in the world who can solve any problems and solution. That's what the only motto we want. This level of skills they should know. Okay, so this is what one announcement I want to do. Otherwise, guys, lots of information, just I'm trying to show in 1 or 2 hours, and lots of information I share with you. Okay, now what I'm doing, any query if you have, anything if you want to ask me live, I'm opening my chat box in a minute. Okay, and you can put on the live chat. Just a minute, please. So live chat, guys, will be open. Okay, in 5-10 seconds you won't see the live chat. You can refresh your page wherever you have access this, and then any query if you have, you can ask to a live chat, or I can ask also my team. I think you guys are the part of the WhatsApp group. Any other query that you have, you feel to ask, you can put in the WhatsApp group also. And further information about the system design courses or earth program, we also put in your WhatsApp group the links and the other information. My team can also coordinate with you any query you want to have. I think we have some form also we put in the chat box. Wanted to know about system design courses on the earth program, or any other technical queries also you guys can ask. But this is the one. Even though, guys, I can give the guarantee, the HotStar, this use cases, okay, if you see, you will find none of the YouTube video, none of the blog that cover everything. Okay, some of the part you can find somewhere here and there. Okay, somewhere here and there, that's a different point. Okay, but in the consolidated form, but the way I giving you a lot of internal knowledge also in my explanation, that level of knowledge I don't find you will find anywhere in. If you plug together all the blocks, you will not find it, right? So I share a lot of knowledge from my side, but I'll try to give as much as I can in 2 hours. But that's all. So use this information, this video is there on YouTube. You go back if you want to revise it, revise the contents. That's all. Any query if you have, thank you, MN session. Thank you very much for this knowledge. Thank you, Dilip. Thank you, Patara. Thank you, Jibran. In the meantime, Instagram system design field, I'll try over the way Kalu, that I can create one multiple videos soon on multiple different system design for Instagram and for Netflix, and again in the HotStar also. Okay, there's a one live streaming services, but again they have a different service for continuous watch. There's a different system design there. Okay, so I'll try to come up with a multiple more live this kind of training where I explain you other system designs also to give more internal deep knowledge that is not mostly available in the market. So at least those who wanted to know about a high level overview about what kind of service they're using, and I'll definitely come up with some more concepts. Thank you very much for including System Art 3.0 free. Great session. Anyone can be part of it. Thank you very much, Samita. Okay, great, sir. Thank you. Yes, Akash, Kubernetes is no doubt very much useful. I highly recommend everybody should know Kubernetes. It's one thing. It's not on the HotStar. Almost all the big platforms use Kubernetes like anything. How you will train us for approach system? Prashant, system design, I'll start the thing from very zero. Every bit I will learn multiple use case we're going to solve practically. Then we go for the next component. After we move next component, I'll show you how to integrate it. Slowly as you know more and more component, then we integrate, and finally at the last go you will see entire component connect together and solve one big use case. Okay, most something like the HotStar I explained to you. Okay. No, a million system design does not require programming skills. The way I create a system as a program, there is no programming skill. Even though we have one entire module here for full stack development, even though you guys don't know any programming, in the full stack I will cover everything about programming, how to create REST APIs, everything, how to use, because after knowing this we can very quickly create microservices also. So if you don't know anything about programming, don't worry, we will cover over here. Okay, you guys get full time. Thank you very much, Prashant. I want to be part of Earth 3.0, but I done graduation from non-engineering field. Vijender, we are allowing only pursuing a student from the technical field, maybe BCA, MCA, MTech, BTech. Okay, or maybe if you are 2022 pass out, that's also allowed in Earth 3.0. Okay. Yes, Webhow at content level auto scaling and buffer server achieve scalability 4-star, right? Yes. Okay, this is a one high level term we can use. Okay, so Kubernetes is doing the content level auto scaling. Okay, but for the Kubernetes cluster, we are going for the buffer level of kind of strategy. Okay, so we have before we can give we have created some kind of pre-created plan based on the chaos engineering, that if out of 1000 million we always need that level of Kubernetes cluster, so they will be pre-warm it, pre-created it. Okay, so both the things work together. So yeah, so what you're asking is right, that's what we have here as a high level. Obviously there will be much more thing to be added. Okay, to be added. So but typically I want to give a name here. If you want to take the name from my side, so there's two different kind of scaling policy. One is traffic based, one is called ladder based. Not leather, ladder, LADDR, ladder based. Okay, so here there's two policies we use. Okay, one is I'm talking about scaling policies. One is the traffic based, this is mostly used especially in the auto scaling world, and what's called ladder based policy. Okay, traffic scaling is mostly typical use as a traffic increase, RAM CPU utilization been gone, then we add more computers called auto scaling. That won't work in the kind of spike or the tsunami effect. In ladder based is like a proactive way. So if we can create a ladder, ladder, that 1 million user I need 10 computers, 2 million user I need 15 computers, 3 million user I need 20 computers. So in my chaos or my load testing, we have come up with this kind of conclusions. We have this conclusion table and we keep on monitoring, and as we reach till here, okay, we launch this ladder. Almost till here we launch this ladder. So we have pre-warm computer ready with us. So if sudden aspect come up, okay, we have the ladder already available. So we don't have to manually launch one by one. We launch 20 more computers, 10 more computers behind this, right? So so Weber, I think what you're asking is to give a better name. HotStar using ladder based scaling policies, not the auto scaling typical policy. That's what they use. Otherwise you can read further about ladder based in on some blog. You can find more information here. Okay, Vinay, microservices, some part is there in the microservices. It's not the entire microservice there in the system design. Whatever we need in system design is there in the microservices. But still we have one more specialized course purely on the microservices that cover everything about the microservices. Good thing is for the Earth student, that course is also free. We have included this course this year and there's a free, this is what I added. So we have this microservice core for Earth that we already make it free long back. But if you anybody want to do a microservices, is again absolute course that cover everything about the microservice. The one of the biggest program of the microservices available. That too a part of Earth 3.0, but in system designs, most of the portion is there, not everything that is being required is there in the system design. Okay, but in system design, not everything is there in microservice, but in Earth, everything is there. Because for us, the Earth is the one of the most critical platform to create the top engineers in the world. Yes, Prasad is enough. Don't worry. 6 months is enough to complete this. Okay, we already have the calendar planned with us. Obviously, we have to give more time, a number of hours. Okay, but yeah, 6 months is enough to complete this. So that's all, guys. I believe the knowledge that I have provided you here about this use case is great. Use this knowledge, even though this knowledge was sometimes very much very beneficial. If you come to this knowledge and in the interviews, if you explain this use case, especially this architecture, because these two guys if you connect, they give you connect actually on the live streaming. Then showcase this architecture, give you a lot of benefit in your interviews. I'm not saying it will help you in the entire interview, but yeah, it will get a lot of benefit in system design interviews. They help you. But again, as a simple note, this video is not for preparing you for the interview. Okay, this video is to give you the high level system design used by HotStar in that particular use case of the India-New Zealand cricket match. That was the plan that I covered successfully. That's all, guys. That's all from my side, and see you maybe in some other this kind of video, and take care. See you. Bye. All the best.